So we're going to continue with this program in Python. I think you can understand now why we've decided to use Python. It is significantly easier. So let's see what else we can do in Python. I can surround hello world in double quotes, or I can surround it in single quotes. Python doesn't care. I also want you to notice that there are no semicolons after each word or after each executable line of code. Python doesn't require semicolons. So I have hello world, and this will also print. One is surrounded in double quotes, one is surrounded in single quotes. Python doesn't mind the difference between the two. But what I do want you to notice is that I forced a new line. There is a blank line between my two print statements, but when I look over here at the run of my program, there is no blank line between them. Just like HTML will ignore white space, Python and Java and C++ for that matter, for the most part, will ignore white space. And so if I want to force a new line or some white space, I'm just going to use the word print. And what print does is it will print whatever it finds after the words, and then it forces a new line. Well, if there is nothing after the words, then it is an effective way to just force a new line. All right, so not only can I print string literals, but I can also create variables. So I'm going to create a variable called greeting. I'm going to set it equal to a string literal. How about something like, what a wonderful day. And then let's see if we can print the contents of that variable. All I have to do is say print, and then call the variable by name. And I'm going to run the program and see if it will print out whatever it found in that variable. I can see that the print statement all by itself did indeed force a new line. So I'll say print. And then how about, I'm going to separate these just to give myself a little bit of room. That white space is not going to display. So how about if we can print a number? What if I create a variable called number, and I set it equal to some number, some random number? I can also print the contents of numeric variables. And we're going to find out that if I put multiple things on the same line, I can print the greeting, and then comma separate that from the other variable called number. And let's see what it does. If I press the run button, now I see that it has printed the two words, the contents of the two variables, and I want you to notice that there is a space between the contents of the first variable and the contents of the second variable. That's because I used a comma separator between the two of them. We're going to find out later that there is another separator that I can use besides the comma that will have different results. So what I'd like to do is find out what happens if maybe I type something wrong. I'm going to come back up here to my hello world, and I'm going to remove the closing quotes, double quotes. And it says to me bad token. It throws an error message and it says bad token, and it says inside of here, it's showing me what the token is. It doesn't know what the double quotes are. It's having a problem. If I return the double quote and run it again, my error should go away. What happens if I accidentally forget the first quote? It's going to say bad input world. It doesn't know what world is. It thinks hello might be a variable, and so it's willing to print out whatever it finds in the variable called hello, but it doesn't know what world is. And so if I put those double quotes back, what happens if I accidentally spelled greeting wrong? I created a variable called greeting. I set it to something, and what happens when I print it out if I accidentally spell greeting wrong? Now it's going to tell me greeting is not defined, and it's even going to highlight the line of text that it's having a problem with. It doesn't know what greeting is because Python is case sensitive. What happens if I capitalized greeting? Once again, it doesn't know what capital greeting is because when I created the variable, I created it as a lowercase greeting, and Python is also case sensitive. What happens if I spell a keyword like print? We've been using print over and over again. What happens if I accidentally spell one of my keywords or my reserved words wrong? Bad input number. It doesn't know what that is, and so it'll highlight the line of text that it has a problem with, give me a chance to review it, see if I can figure out what's wrong with it, and then fix it and try to run it again and see if my program runs correctly. All right, so we found out that we can create variables and we can print variables. We can print string literals. I'm going to create another variable and we'll call it greeting2. And I'm going to set it to something like I am a greeting2. And then I'm going to see what happens if I print greeting. There is another separator besides just the comma that I can use between two string values, and it's the plus sign. So if I print on the same line greeting and greeting2, because they are both string variables, when I run it, I want you to notice the difference between the first one and the second one. When I use the comma separator, it automatically put a space between the two variables. If I use the plus sign, it concatenates, or it just mashes them right up next to one another, and so there is no space. And this is going to be very valuable information to me as I move into my program. So just like Java and just like C++, we can add comments to a Python file, to a Python program. The symbol that I'm going to use is a pound sign, and anything that follows that, this is a comment. They're notes to self, instructions to me, and they will be ignored by the interpreter or by the program. And so I'm going to create another variable. We'll call it miles. I'm going to set it equal to 26.2. I can also add comments to the end of a line. Anything that follows that pound sign will be a comment and is ignored by the program as it is run. So I can also print a mathematical calculation. So let's see if we can print miles times 3. I'm going to run this program and see what happens. Now it gives me 78.6. I'm going to push this down just a little bit so I can give myself a little bit more room to see things. I'm going to force a new line there. And then we're going to talk about the problem with leading zeros. Remember we talked about the different formats of an integer or a whole number when I am printing it. So what I'm going to do is I'm going to create a variable called 0, and I'm going to set it equal to 0, 0, 0, 1, 0, 0. And then I'm going to print that variable 0. What do you expect that it would print? Well, from everything I see, I expect it to print 000 1000, but it doesn't. It prints 512. If you'll notice, the three leading zeros are red. That's because if we go back to the presentation, which, by the way, you have access to in your Canvas module, you're going to notice that a leading zero, if it starts with a leading 0, then it is actually an octal number. So what it is displaying to me is 1000 in decimal is actually 512 in octal. If I wanted it to print out in some other data type, I could set 0 equal to, let's start it with a 0b, 1, 0, 0, 1. So I'm going to set it equal to 0b, 1, 0, 0, 1. And now if I print 0, what do you expect it to display? Expect it to display 9, because 1009 is actually a binary, 1001 in decimal is actually a binary 9. And so that's an example of how a leading 0b or a leading 0 or a leading 0x can actually change the data type or change the way that it's displayed or treated in Python. So you want to be careful when you have leading zeros. Another thing that we want to be careful of is integer or division. Problems with division. And so I'm going to create a variable, we'll call it minute, and I'm going to set minute equal to 59. And then I'm going to print minute divided by 60. And I'm going to ask you, what do you expect this to be? Well, 59 divided by 60 should be something like 0.9998 or something very, very close to 1, but not quite 1. But when I print it out, I see that it is displaying a 0. That's because I'm doing integer division. I have defined minute as an integer variable because I set it to an integer or a whole number. And when I divided it by a whole number, I did what is called integer division. Integer division ignores anything after the floating point. It doesn't round up and it doesn't round down. It just flat out truncates anything that it would normally find after a decimal place. And if 59 divided by 60 is 0.9998, when it truncates the decimal place and all of the numbers after it, it just leaves it with a 0. If I wanted to do floating point division, I could divide it by a floating point number, such as 60.0. Minute is still an integer or a whole number, but now 60.0 is a floating point, and the very fact that I have a floating point in my mathematical calculation is going to change the entire math statement to floating point, and now when I run it, it's going to give me the actual answer. Another one of the options might have been to create the variable minute 1. I'm going to create another variable. This time I'm going to set it to 59.0, and now when I do division with minute 1 divided by 60, because minute 1 is a floating point and 60 is an integer, it's going to do mixed division, and it's going to give me the right answer this time. So it's very important that we are taking into consideration whether or not I'm doing integer division or whether or not I'm doing mixed division or floating point division.